My name is Tim Sutton, and I'm from Montreal. Thanks, Matt, for having me back. I love this conference, and I couldn't make it last year, so really happy I could come back for its fourth year. So first things first. So I heard somebody this morning saying that the reason, like the last two letters come from whatever was the nearest train yard. I didn't really know what that would correspond to for Montreal, so I did some Googling, and this got to kind of, not the root reason, but the reason why they have the U and the L is apparently, so there's next to the airport of Montreal, there's another suburb called Kirkland, and in Kirkland, there is a air tower that emits UL in Morse code, and I guess that was the nearest thing that was there when they built the airport. And I learned that you can translate U to UL to English with DD, da, D, da, DD. That's another new thing I learned this morning. There you go. So I work at this company called Sauce Labs. In case you're not familiar with what we do, we run a continuous testing platform primarily used for end-to-end integration testing, regression testing, QA for mobile and web applications. So this is originally, it utilizes an open source framework called Selenium and a sister project called Appium. But we're also working towards also supporting native testing frameworks like XCUI test as well. So this is me picking starting a manual test that runs in an iPhone X simulator in a VM. It also is going to run all of its traffic through a local tunnel proxy on my laptop so it can access internal resources. This is another shot of me stepping through the Mac DevOps website. I think I tried to click on the Eventbrite ticket link, but tickets were sold out. And then I also tried out a feature we have called extended debugging. I just tried it for the first time this week, and I found out that there's a header on WordPress has a project called batcache, and they put a header called x9999 batcache in all the traffic. And I didn't know about that, so I learned something else. And apparently that's very old news. That's been around for like 5 years. But so we run all these tests in a short-lived VM instance that we create on demand for every single test that runs through. And that means that we actually spin up and we cycle through over 1 million VMs in a given day. So if this kind of thing is interesting to you, come chat with me afterwards because we're hiring. So the talk about dependencies. When I say dependencies, I'm talking about any kind of software packages, language libraries, Git repos, installers, Docker images, really any kind of upstream project or artifact that you rely on for software that you use or you write or that other people use. If you install software on client machines, sort of client platform management type work, the OS that you are installing to is a dependency in and of itself, the libraries that it has on the OS. So there were 2 events that took place in February within a very short time frame that kind of made me realize that this was a topic I should talk about here, which apparently I have a lot to say about. So I'll refer to a couple of these stories in just explaining some of the concepts around dependency management that I think would be useful for like this audience, given the context I know about sort of where people are at and what different areas people work in. So the first event that I wanted to bring up was that, so some of you are familiar with AutoPackage. It's a Python tool that lets sysadmins automate fetching and processing and importing third-party software into a repo like Monkey or Jamf. And so since the very beginning, it's had no reliance on any third-party Python packages. It's always been like strictly just requiring Apple's Python that ships with the OS. And the advantages there is that it's made it super easy for anybody to run that code. There's been no environment setup required. We don't have to require people to like use a different Python or anything like that. It's made it very easy to use also the Python Objective-C bridge. So Monkey has a similar philosophy where it's like there's so much friction removed from just using Apple's built-in Python. But as many people probably here know, the Apple's Python is not a good choice if you have to do anything with secure HTTP connections. And it's been getting worse over the years, although I guess now it's finally better because in 10.13 and up, they use LibreSSL. But up before then, it's always been linked to this really old version of OpenSSL, and Ruby's had the same issue as well. They keep that old OpenSSL around for reasons that are not, they don't care about whether like Python works with HTTPS. Like that's not, there's other reasons why they have that around, but so we still had this code in AutoPackage. Like we had already moved away from using native Python libraries for things like scraping download sites and update feeds because so many other servers have been like hardening the security requirements over the last few years. Somehow though GitHub hadn't done that until very recently. So because it is for we use their API to do search within within AutoPackage. So eventually this did finally break. They announced it a year ahead of time, but just none of us saw it. But so we had this dependency in AutoPackage, which is like we're depending on both the crypto libraries that come with Mac OS, and we're also depending on the GitHub API itself. So if we're going to decide that we're going to use the GitHub API, we have to really treat that as another dependency of the project. I think like a positive step forward here would be to actually include our own Python with AutoPackage. So we already build an installer package for AutoPackage to install it, so it makes it very easy for people to install. But we'd still have to consider that there's a cost to people contributing to the project or testing it out if we're going to make the environment setup much more complicated to be able to use it. So we would have kind of more better probably reliability in terms of how it works on the client end, but from like it's a small kind of community-driven project, so the easier you can make it for anybody to like test changes to AutoPackage, then the better. So, but that would be an interesting thing to consider that we were talking about. In the end, Hannes, who's also been doing maintenance on AutoPackage, ended up just switching out to curl like we already had for other parts because that was the simplest solution. But there are people who work on similar kind of ideas. So Clayton is back there. So he wrote a project has been working on called Vendored. The idea here is exactly that. So it's like a set of scripts to be able to compile Python, I think Ruby, OpenSSL. It will also install PyObjective-C and actually a much more newer version than what Apple includes. But the goal here is to really have like a Python that you can ship along with other management tools. So if you need to work around this limitation with Apple's tools, and you want to like have better control over your runtime that you know your utilities or your application is going to use, you can use something like this, and it handles actually building an installer package and letting you sequester it away to an area that's not going to conflict with any other vendor packages as well. So really cool idea, and I think also this is kind of in the same spirit of a project that Google has been talking about for a number of years, where they've been shipping their own Python to use with Monkey and their other management tools. So this is a talk from Mac AD UK from last year from Clay, a different Clay. So this reminds me of a conversation I had with somebody. I was at PyCon a few years ago when it was in Montreal, and there was somebody I spoke with, I had met for the first time at breakfast, and I was explaining to him like how in the sort of Mac admins community, there's a real interest in using Python, but we're not really coming at it from a developer perspective as much. We're usually looking at, how do we get it onto the client systems? How do we use it to like interact with the clients for management reasons? How do we get more people involved in even using Python, like people who previously maybe had only done bash scripting? And his response was like, well, it's just pip install. Like, just pip install whatever you need. Like, what's so hard about that? And it's a good question. So it made me realize that there's a very different context that sysadmins and particularly like Mac admins operate in compared to somebody who is, for example, a Python web developer. in terms of how you manage the dependencies. But I still think, so it's important to understand that concept, but it's the more we can understand about the tools that the Python community or other communities have for managing their dependencies, then we can kind of level up how we manage those things as well. NPM Part 1. So NPM is a node package manager from a category of software that I'd call library package managers. We've talked already about why there's reasons that you'd want to use a stock, like the built-in standard library for something like Python, for example. But then there's many reasons why it's actually a good idea to use something third-party to build upon the work of other people. So there's huge amounts of third-party packages out there, so why not use those for your project if you can? So these LPMs are able to go and fetch packages for a given programming language library. So on February 21st this year, less than 24 hours before that GitHub TLS-related issue I was describing, this issue is opened on the NPM project. And then this is part of the description. So it says, I found that a selection of directories in / were owned by a non-root user after running sudo npm, and many binaries in user bin stopped working as the permissions were changed. People experiencing this bug will likely have to fully reinstall their system due to this update. This was NPM 5.7.0. And so, of course, this thread made it to the top of Hacker News and has a long thread on GitHub. Eventually, the thread was locked, and people tweeted. People later deleted their tweets and apologized in the thread. People approved of the flaming dumpster fire animated GIF. I don't actually approve of that, for the record. But so this issue, though, really struck to the core, and it's kind of like what Henry was talking about in terms of managing permissions with package managers. It's always an issue that I've had that these tools often default to trying to install to whatever the site packages directory is that kind of comes with that installation. But on a Linux system or a Mac system where we have often these tools pre-installed, we don't necessarily actually want to leave it up to the package manager to know how to set permissions on a system-wide folder that's owned by root. It's not realistic to expect a tool that has to function for every single OS and OS flavor out there that it's going to always get the permissions right, and possibly be conflicting with a package manager that's already sort of has that responsibility on that OS. Rubygems used to even automatically retry to run a gem install. If it tried the first time and couldn't do it, it would actually rerun the install with sudo, like without telling you. And it just did it. It didn't like ask you if you wanted to. It just did it. So if you had run sudo like 2 minutes before in your terminal for something else, and then you did a gem install and you forgot to like switch to your Ruby environment, like you've now installed stuff into your root folders, right, without even realizing it. Before SIP, this was even worse because you could actually screw up your site packages folder inside /system. Now you have different issues, but at least you haven't tainted your system folder. But yeah, Rubygems doesn't do this anymore, and I don't know exactly how that even happened, but yeah. So having thought about this, I'm kind of proposing 4 different steps you can take to kind of get control back of anything that has to do with library packages and dependencies. And I kind of consider them in this order of importance. So kind of the first one is sort of a foundation, and then you build upon that. We'll be mostly talking about Python and Ruby in this because I think those are kind of the 2 most common languages that people here are familiar with. But these concepts apply even to things outside of just package management, like Docker images and infrastructure and whatnot. And I kind of liken this a bit to learning Git in the sense that we all kind of learn just enough to be able to get by, and that's fine. But this is actually a lot easier than learning Git. So I promise you it'll take you way, way, way less time. So we'll look at isolating packages first. So first rule, don't sudo install stuff if you really can avoid it, unless maybe you've got some really good reason for it. If you at least avoid doing that, then you'll avoid the case where you've accidentally overwritten something in like your /library, /Ruby, your Python directories. You'll always be isolated within just your own users folder, where at least you won't be messing with system permissions. Also, when you have everything installed for a given project inside some kind of environment, whatever environment that particular language is using, it'll always be isolated from any other project. So you can have versions that might differ across different projects, and that's fine because they're isolated in their own area. And then also it makes it easier to take your project and then portably install it on some other OS, like even possibly Windows or Linux. Like if you have already some setup defined of what packages it requires. So for Python, just as an example, this looks like you get the virtualenv command line tool. I also like to install this other one called virtualenv wrapper. I don't think these names are great, but it's what we have. You then use virtualenv to just create a new virtual environment, give it a path that you want to create it at. Again, the make virtualenv one is from the wrapper tools, and I like that one because it doesn't make me actually have to type out the path that I want to use. It just manages that for me. Virtualenv wrapper also installs a utility called workon, which makes it very easy to just quickly alt-tab switch between different environments. And then once you're activated inside a Python environment, then you just do your pip installs. You don't worry about whether you have to use sudo or not. You just don't have to. It'll handle isolating whatever package installs into just the environment you're in. So with Python, it will typically look like this. So yeah, these are different environments that I happen to have on the system, on my laptop, and I can just see them all at a glance, and I can just tab complete through them. I can list what I already have installed in that environment, and then you type pip freeze to output to a file called requirements.txt. That's just a pattern, but it doesn't have to be even called that. But then that'll output a list of all the things that you did install, and in such a way that you should be able to repeatedly install those same versions. The Ruby example is sort of similar. So we install something called bundler instead. You define in a gem file what versions of different gems you want to use, and you can constrain them as closely as you want, or you can make those very loosely defined. When you run bundle update or you run install for the first time, it will actually go and resolve all the dependencies that it has figured out between those different gems as to like what things they depend on, and make sure that it's going to be able to actually install everything you've asked it to. It saves this to a file called gemfile.lock, and that's like that pip freeze output in a way. It's exactly what versions that thing installed, and you check both of those things into your source control. So you have a record of what you'd like the project to use as like a loose dependency, but then it also records exactly what it installs, and you also check that into source. Later on, you just type bundle update to update that in the future. And you run everything with bundle exec. So bundle exec is the thing that actually will make sure that it's pulling in the right versions of gems that you've defined in your log file. So the example equivalent to Python here is like, so I define this one thing that I want in my gem file. And when I run bundle, it's going to actually list out what all the transient dependencies for those gems are. And it's going to save that as a file. Later on, let's say, OK, I'm finally ready to move to Sinatra 2. I just replace that in my gem file, and when I rerun bundle install, you'll see like the places where it actually updated from 1 to 2 version. And then that'll update the log file as well. So those are patterns around isolating the packages. For the runtime, this isn't necessarily always required. I find personally I don't need to do this really so much with Python, because Python versions I'm typically using Python 2.7. But it's helpful to be able to have support in your project to do this, because it still makes it very easy to port it to any other kind of environment, or like a Docker container or some other OS for another developer to work on. Has everybody seen this XKCD from like a couple months ago? Right? It's like if you've used Python long enough, especially when you start out and you find different ways to install it through different tools, You've got the homebrew stuff somewhere else. You've got like 5 different Python installers. Some of them install a pip that kind of goes with it, but you don't really know which one you've ever got set by default. And there's even an explain XKCD that actually lists out all the different. I didn't know about this one either. Maybe somebody can fill that out. So the reasons to have that runtime isolated is that even if, like I was saying, you only intend to use Python 2.7, having an isolated, like separate runtime that's pulled from somewhere else, you'll avoid the issues with the crypto libraries on Mac OS. You'll avoid, if you're using Linux, you'd avoid any changes that might happen if you decide to change the underlying OS, like you want to upgrade, to a different Ubuntu image, or you want to switch to like Alpine Linux or something, and the packages won't necessarily be the same thing. For Windows, like you're going to have to install Python anyway, so you might as well use the same tools that you can use on Unix as well. Again, the idea here is really just isolating the interpreter from whatever came with the OS, so that you just remove that variable entirely. And if you do this step, it actually makes the package isolation step I talked about earlier easier, because the tools that you use to install the versions will typically also handle installing like a pip or a gem binary or executable that is going to be paired with that version of the interpreter. So this actually, I don't consider this as important as isolating packages, but in many ways it's complementary and it makes it easier. Some different tools for this. Python has one called PyEnv. I haven't really seen anything else that seems like the most popular one. For Ruby, there's a few different choices. I like the last one, Ruby install and Cheruby, because they're both very, very simple utilities. They're written by the same person, but they're independent. Cheruby is like 100 lines of bash, so it's like a very, very straightforward way to just switch between Ruby versions. It doesn't, RVM like overloads your shell aliases and whatnot, so people have often moved away from that because it seems like it kind of alters too much about their shell environment. And then Node and Go, I don't work in as much, but I know that there's version management, like NVM and Go. I'm even less familiar than with NPM, but GVM is one of the Go management or version management tools out there. On the Mac, you can use Homebrew actually to get different versions. Like you can brew install an older major version of something, but I personally think that this makes more sense to use a tool like this because it's OS agnostic. So Homebrew is great for your Mac, but if you want to then take the same project and run it on some like Linux machine or a Windows machine, then you already have knowledge about how these tools work and how they are set up and everything. Or if you're using Docker, then all those programming languages already have Docker images that are versioned to a given version. So you can already like run your code through a Docker image that is like tagged from a specific version of Ruby, for example. So version pinning. The idea here is that you can in a pip requirements file, you can define the versions very loosely. You can say, I'm just going to give me the latest versions of the requests package, or you can pin them so you can say, well, I know I just need to have at least this version. It can't be lower, but it's okay if it's higher. I recommend not actually doing this in the project code itself that you're checking in, because what you want to do is remove the possibility of surprise when, say, 6 months down the line, you try to set this project up from scratch, and there's now a newer version of some library that you used, and it's not backwards compatible with your code, or you're calling something that's no longer supported. You don't want to have somebody else check out your code either and then not be able to use it, ideally. So what's also nice about if you have the version specifically in source control, then you'll have a record of like why you updated the version at some point, like in your Git commit, hopefully, explaining, okay, now we're moving to this version because whatever. It was released for security reasons, or we need to take advantage of some new feature or something. And then a nice side effect of this also is that if you have people building internal packages that you publish somewhere, you can also pin, or actually not even for internal packages, but if in just a fork or a patched version of some library, you can pin your dependencies to like a very specific branch or tag or commit from some other forked repo. Again, what I like about bundler versus Ruby or versus Python is that you'll get the version pinning for free just in how it's designed to output the versions to the lock file, and that's what your next install will use. And pip doesn't actually have a dependency resolution system, so the pip requirements thing is more like just a series of steps. It does kind of do them in a batch, but it's not going to necessarily be able to know that if you have a conflict in the dependencies, then it's not necessarily going to figure that out ahead of time for you, whereas bundler will. As long as all of the different Rubygems have already defined like what versions of their dependencies they support. And this has definitely bit us in the past at work. And one interesting thing that happened recently was that I think that over the years there's been enough cases where we did a build environment setup and had an out-of-date version of pip for maybe it was like the command line options were no longer compatible, or there were like TLS related stuff that forced people to need to use a newer pip. So we had this at the beginning of a lot of different like build steps in our build pipelines, and then when we found out when pip 10 came out that we had code like this where we were like calling pip as a module and we're using it directly within the Python code. That didn't work with Python 10 or with pip 10. So actually during that week that pip 10 came out, I literally like every day of that week throughout our build pipeline, we would run into one case where one particular project had to be built, from scratch for the first time on, say, the Wednesday that week, and we find out that okay, they also had like a pip automatic upgrade that broke something in the code. So the funny takeaway here is that even your package manager is its own dependency, unfortunately. So you can actually be bit by just even forcefully always upgrading the package manager itself. Not really an easy solution around that, besides if it's really critical, then you can pin the version of pip as well and just try to take care to upgrade it as you can. And then mirroring. So anybody can guess what story I would tell about mirroring in NPM? LeftPad. So a couple years ago, there was so with NPM development, there's much more like, the dependencies can go a lot deeper. One project can depend on another project, and the complexity of that dependency tree is much more complicated with NPM. And so it's very easy for like a huge number of projects to all indirectly depend on one single package, and that's what happened with this LeftPad package. It's like an 11-line JavaScript function that everything depended on. And so the developer had to pull it from the NPM registry for legal reasons. And it basically, what people were saying is like, you broke the internet. Nothing was able to be built the entire day, including Node itself, amazingly. So, and you can, LeftPad became used as a noun, and I think also a verb. It was just like, it's huge. It just made people realize how much they could improve their process by not depending solely on upstream source. Somebody also made a site called leftpad.io, which was like leftpadding string manipulation as a service. So it's like a little microservice that you can just curl and it'll leftpad your string. Actually, it's a really funny site if you go and read it. But so the reasons why you would want to do mirroring. So it's one less point of failure. So if you, for example, at work, we have a lot of part of our process has to go through a very lengthy end-to-end build, and there are so many different components in that which have to do like a complete setup from scratch. And if we had to do all of those setups always from PyPy every single time, we would have too many places where it fails just on the off chance that PyPy is overloaded or down temporarily. So if you have a mirror for all these packages, you have just one less point of failure. It's probably faster if you have it installed in the same place in your network as the machines that are pulling down the packages. So even just these two reasons alone, I think, make it worth doing. It also has a side benefit of letting you host internal packages. So if you have people committing something that's private, it's not going to a public registry. If you've already got a mirroring solution set up, then you can publish your internal packages to that same server, and that's just one less thing you have to have a separate solution for. And then in the case for LeftPad, you have those archives available locally. So you have, from one side of the coin, you don't have everything stopping working as soon as one package has changed its state on the registry, because you have it already on your local mirror. And then you've also got the actual binaries or built packages like on a disk somewhere that you control. So particularly if you use something like Reposado, or you mirror Apple updates, or you cache any other kind of third-party software, if it's not software that you can actually build and compile yourself, it's even more important, I think, to have some kind of way to mirror those, because Apple, when they release 10, 13, 6, or whatever, they will not be obliged to keep giving you various installers that you might have still needed for a previous build or a previous version until you're ready to use the newer thing. So yeah, and so for binary installers, it's particularly useful. There's a tool for Python called Dev PI, which I thought was pretty great. It transparently caches things locally as you request them. So unlike Bandersnatch, which is more just like a full pip PyPy mirroring tool that goes out and caches all of PyPy, DevPy just does it as required, and you can publish private packages to it. Ruby has an equivalent called Gemstash, which is very similar to DevPy. And then a couple people mentioned Artifactory today. So Artifactory Pro has repo types for everything. You can do Helm charts, Docker registries, all the different programming language package manager types, Java. There's Vagrant images even, but it's very, very expensive. But it's one of the things that it does really, really well. And then just last but not least, since Henry was talking about brew, I did find this one really neat utility. It's a custom brew command that somebody wrote, this gentleman, Yifan. And it is, you can brew tap his repo, and it will give you a mirroring command that you can just type bottle mirror. And it just goes to bin tray, and it starts just it mirrors the entire list of all the built binaries that exist on bin tray. And you can run it again tomorrow, and it'll just find whatever new things have been added since the previous day. So it's really useful for just having that local backup. If you ever needed to roll back to an earlier version of some package for a build machine or some kind of CI automation you're doing, and you find out that, okay, Homebrew, you were using it to bootstrap the environment, and now they've updated to a major new version of something, and there's an issue with that for what you're doing. This way you would already have a cached binary on hand. You can always just install it yourself. And what's nice is that he also made this work inside a Docker image. So you literally just run it, it starts mirroring. And then in order to actually use it, you just have to define an environment variable called homebrew bottle domain. And brew will just use that instead of bin tray. So it's really, really simple. It's 100 lines of Ruby, and most of that is just multi-threading stuff. So that's it. I have a blog post that has all the links to the various things we talked about. And yeah, thanks for having me.